So I welcome you all to this doubt clearing session of the course Engineering Thermodynamics. So let me first take up some of your queries from the quiz. Okay. So you are having few queries about specifically about first question. The very first question is that when rotational kinetic energy of a molecule, rotational kinetic energy of so the question is, so rotational kinetic energy of a molecule, it is 0. Okay. So this was the question that we were having some monoatomic gas. Okay. So we were having some monoatomic gas, and for that monoatomic gas, our rotational kinetic energy would have been 0. But none of the option was correct. Okay. So because of that, what we will be doing, this particular question will be discarded from evaluation. Okay. So this is the first question. Then next question was that what is the reason for rotational kinetic energy to be 0? So reason for rotational kinetic energy of molecule to be 0. So there were certain options which were actually confusing. For example, one of the option was that if center of mass and center of axis is coinciding. One of the option was center of gravity and axis of rotation are coinciding. But the correct answer would have been if the mass of the atoms is actually located on the axis of rotation. Okay, so that would have been the correct option. That we are having a situation where mass of molecule coincides with axis of rotation. So that would have been correct option. So that was, these options were confusing, and at the same point of time this question is actually repeated also. So this question is repeated. This question has come 2 times in your quiz. So I am discarding now this question also. Okay, and then there was 2 more questions which were having the issues. So one of the question was about atomic structure, and one was about molecular structure. So these were also the confusing questions. So appropriate answers, appropriate questions would have framed like that: if there is changes within the nucleus, if there is change within the nucleus, then we will be having nuclear energy, and if there is change in atomic structure, means if atoms are actually changing, their bonds are breaking and making, or if there are changes within molecule. So if there are changes within molecule, then we should have the correct answer as chemical energy. So these 2 questions also I am discarding at the moment. Okay. So now we have discarded 4 questions and 1 question is repeat. So that's why 5 in total, 5 questions are discarded, and we will be having evaluation or marks out of 25 only. Is this point correct?
Sir, 12.5. Okay, sir.
Yes, sorry. Yeah, marks will be out of 12.5. So we will be having 25 questions and marks will be out of 12.5. Okay.
So could you tell please that why is that question being discarded about rotational axis and center of mass?
Okay, so for rotational axis, it may happen, for example, if I take a molecule, say this is my molecule, okay. Say this is my diatomic molecule. Now for this molecule, if I say my center of mass may be at this particular point and my axis of rotation may be this one. So now in this case, you can see that center of mass and axis of rotation are coinciding, but still if your molecule is rotating about, so your atomic masses are at certain distance from the axis of rotation. So these atomic masses will be contributing towards the rotational kinetic energy about this axis. However, if my axis is like this, then my rotational kinetic energy will be 0. So it means it will be 0 when my masses are located on the axis of rotation. Okay, so that's why it is actually taken as like this.
Sir, but at the atomic level, can we can also say that that center of gravity is same as center of mass. So both of the options should be correct.
Yes, in that case, both should be correct, but it has created a lot of confusion in many of the students. So that's why I am actually discarding this question also. Okay.
Yes,
So
sir.
because,
Thank you.
yeah. Okay.
So one more question, sir.
Yes. Which one?
Latent heat stands for it should be absorbed heat.
No, so it will be absorbed heat when we are changing from liquid phase to vapor phase. During that time, this will be as absorbed heat. But when we are transferring our substance from vapor phase to liquid phase, during that time it will be released. So at that time also we call it as latent heat only. Okay.
तो सर आंसर क्या हो जाएगा? Absorbed heat.
Absorbed heat. See, absorbed heat, it is a type of absorbed heat also, but in general, it is actually a hidden heat. Okay, because it can be released also. So in generalized form, if we say, if we have specifically written that during liquid to vapor phase, then obviously absorbed heat will be true, but we are writing latent heat in general. So in general, it's a hidden heat. Okay.
Sir, how latent heat is hidden heat?
Hidden heat means because if you are adding the heat, that will not be reflected in terms of increase of temperature. Okay, so that's why sometimes people are calling it as hidden heat.
Sir, I think marks should also be given on absorbed heat because that is also partially correct.
So that is partially, but in general we are asking the statement. So that's why I am not actually including this question. More or less it is only 0.5, so not a big deal. Okay, ultimately you are having option for best n-1 number of quizzes also. Okay.
Excuse me, sir.
Yes.
There was a question, question 28, in which in the answer sheet that you sent yesterday, the question was which of these are extensive properties. But in our question paper, as far as I remember, and some of my friends, we thought that it is intensive.
No,
Yes,
why
sir,
you
in my
thought?
paper also it was
Because
No,
it
sir,
was written
actually-
intensive in our quiz.
Yes,
Yes,
it
sir.
was.
my quiz also.
Actually, sir,
Yes,
the
sir.
question
Yes, sir.
came, the axis of gravity and center of gravity and center of mass question came twice, but it is not showing there twice.
And in this question, we what we could see was intensive, but in the answer key it is written extensive. So now what should we do?
No, you need not to worry. I'll check that what quiz has been gone to you. So probably TA has once again made a mistake. The file he has uploaded on class marker and the file he shared with me, then probably these are different. Okay. So this is the confusion which has been created by TA. So now I have clearly instructed them to carefully look into the question, and moreover, I was actually occupied with something else. Moodle, I have checked the questions, but while they have transferred the questions from Moodle to class marker, they have made lot of mistakes actually. Okay, so I'll carefully look into this, and from next quiz onwards, such mistakes will be avoided. And in particular, if this question you are having confusion, I'll carefully look into it and ask TS to evaluate accordingly. Okay.
No, so actually what would have happened was there were 3 questions regarding intensive and extensive in the quiz which we got as the answer key. 2
Yes.
were from intensive and 1 was from extensive. So I
Okay.
guess what would have happened during the quiz was, since this rotation question repeated twice, so it
Okay.
came instead of that extensive question.
Okay. Yeah, so what I will be doing carefully, I'll be looking into each and every answer sheets of yours, and accordingly I'll evaluate whatever is given to you. I will check into that. Okay, as per the question only, I'll evaluate the options. Correct?
Sir, and
Okay.
one more question about internal energy. Sir,
Yes.
it stated that which of the following are true about the internal energy? Question number 16.
Okay.
Sir, in that question, sir, one option was that it is proportional to the Ke of translational Ke of the molecules.
Yes. Okay.
Sir, but the thing is, U internal, it includes sir Ke, U external also, and U intramolecular also.
Yes.
Sir, but for proportionality, we need only single term, like we had done P is proportional to T, since there is a single term. Sir, otherwise we don't say it as a proportionality. So this created confusion also. Sir, like there
Okay.
are three terms.
I understood, but I think, see, that is what I am saying. But as only one term was relevant over there, so out of three options, or all four options, if you see, the most relevant option was that one only. Okay. So, like,
No, no, sir. Actually, answer is given. All the four options, all the three options are correct. And I thought that the thing is, since it was a single answer correct, so I should do the best one, like it is a state function. So
okay.
yes.
Okay. No, actually, the point is, so probably was it not written that it is having multiple answers, correct?
Sir, no, sir. It was single answer.
Okay, no issue. So it's a matter of only 0.5 marks. So probably it will be like coming with you. It will be nullified if you are taking if you are making your further quizzes best. Okay.
I have one more doubt that are all specific properties point functions?
Yes. Every property, whether extensive or intensive or specific, every property is a point function. Okay. Irrespective of the kind. Okay, so I think one more question, particularly I could locate. So that question was specifically related to isolated system. So let me take up that question. So the isolated one, someone has written about isolated.
Thermal flask.
Yes, thermal flask. So what was the question? Question is.
In the question that I wrote, what I was trying to say is, sir, because as it was mentioned in the question, there was some process occurring, and
Okay.
because it was an isolated system, so mass transfer and heat transfer cannot occur. So
Yes.
there is a possibility that to maintain the equilibrium after the process, some work will have to be done. And in
Okay.
the questions, it was written that no work will be done. So I had a doubt regarding that.
No. So there is like it may happen. For example, if this is an isolated system and inside, for example, if I have mixture of air plus fuel, okay, and this air plus fuel mixture is at some temperature at which combustion can happen. So what will be happening? This air and fuel will be undergoing through the oxidation process and it will be releasing certain amount of energy. So because of that, the thermodynamic state of the system will be changing. Okay. So no work is done over here. However, the state of system has changed. Okay.
Okay, sir.
So
So in
yeah, please.
isolated systems, we consider that no mass transfer, no heat transfer, and no work done.
Yes.
Okay, sir. Thank you.
Now, I think I have taken all the questions which are related to the quiz. Now, let me take up the questions for today's doubt clearing session, whatever you have posed. Okay. So the first question for today is, please elaborate question number 6 of assignment. So let me now take up the question number 6. Before that, just one small thing I want to tell that today, just before this doubt clearing session, I have uploaded a recorded tutorial session, and that recorded tutorial session is for numerical solving based on first law of thermodynamics. Okay, so all of you please go through that tutorial session. That will be helping you in understanding how to approach the solution of problems while you are solving the questions related to properties of pure substance, first law of thermodynamics, and different processes. Okay, so kindly all of you are requested to please go through that tutorial session and ask all your friends, those who are not connected in this doubt clearing session, ask them also to go through that one. Okay. So now let me take up this particular question, which is based on assignment number 2, and the question is written over here. So can you all see my question? I have just now opened the question over here. So the question is, a piston cylinder device contains 0.1 meter cube of liquid water. So let me write the conditions that we have volume of liquid water as nothing but equal to 0.1 meter cube and volume of gas as nothing but equal to 0.9 meter cube. Okay, and you can clearly see it is given in the question that we are having a container, and in this particular container below we are having liquid and above we are having vapor. Okay, so that is given in the question. Now what I have to do, and it is given that the condition of pressure is nothing but 800 kilopascals. So we have pressure of this container as 800 kilopascals. Okay, heat is transferred at constant pressure until the temperature reaches to 350 degrees Celsius. So now what we are doing, we are adding certain amount of heat, and this heat is added until our temperature is reaching a value of 350 degrees Celsius. Okay, we have to determine initial temperature of water. So initial temperature, that is first question. Then second question is total mass, m total of water. Okay, third part is final volume. So total final volume we have to determine, and we have to show the process on PV diagram. So on PV diagram we have to represent this process. Okay, so now let me take up how to approach for this question. So if you can clearly see, the condition is given that initial pressure, say if I write that my 1 is nothing but the starting state and 2 is the final state. So it is given that P1 equal to 800 kilopascals, and it is given that T2 equal to 350 degree Celsius. And one additional information is given. In state 1 we have nothing but mixture of liquid and vapor. Okay, so we have liquid plus vapor. So if we are having mixture of liquid and vapor, it means this is nothing but our two-phase region. Okay, so if this is our two-phase region, we know that if I plot my temperature volume diagram and if I plot the liquid vapor dome, it means that I have some line, I have some constant pressure line over here, and the pressure value is nothing but 800 kilopascals. And we have actually the mixture of liquid and vapor. So that's why my thermodynamic state 1 will be somewhere over here. Now exactly at it is at what point, that I don't know, but it is clear that it is nothing but in our liquid vapor dome, so inside the two-phase region. So you can see that inside the two-phase region I'll be having some temperature over here, and this will be my saturation temperature if it is actually crossing the saturated points. Okay, so if it is crossing the saturation point, so what we have to do, we have to just go to pressure table, and corresponding to P1 of 800 kilopascals, I have to locate T saturation. So whatever the T saturation I'll be locating, that will be nothing but my T1 temperature. Is this point clear to all?
Yes, sir.
Okay, so once we have located T1, now next question is we have to find out the total mass. So if you see in this first state, mass volume of liquid is given 0.1 meter cube and volume of vapor is given as 0.9 meter cube. Okay, so now we know that our volume is nothing but specific volume into mass. Okay, so that we know that our volume is nothing but it is equal to specific volume into mass. So now what will be happening in this particular case? If we know the saturation, that our state is saturated corresponding to 800 kilopascals, I can find out this state, saturated volume of liquid, specific volume of saturated liquid and specific volume of saturated vapor. Is this point correct?
Yes, sir.
Yes, sir.
So I can write that my at 800 kilopascals specific volume of liquid and specific volume of gas is known from the saturated table. So if this is known, what will be happening? Mass of liquid will be nothing but volume of liquid divided by specific volume of liquid, and mass of vapor will be volume of gas divided by specific volume of gas. Is this point clear?
Yes, sir.
So once we are having individual masses, I can define total mass as nothing but equal to mass of liquid plus mass of gas. So this point is also clear?
Yes, sir.
So it means second part is also done. Now let me go to the third part. Third part is we have to determine the final volume. So it is very easy. So now what we are doing, this was our initial point. Now from this particular point, we have started actually the process of heating. So if we will be adding heat initially, and we are adding heat at constant pressure. This is given in the question that while we are adding the heat during that time, pressure is maintained constant. So if pressure is maintained constant, first my all liquid will be converting into vapor, and after that, if we further keep on adding the heat, I will be entering into the superheated region, and I'll be adding this heat till my temperature is reaching to state of 350 degrees Celsius. So once we are having 800 kilopascal pressure and 350 degrees Celsius temperature known, now by using the superheated table, I can simply find out the value of specific volume.
Yes.
Okay. So final specific volume I can determine using superheated state. I can call this as nothing but specific volume corresponding to state number 2. Okay. So now mass I already know. If I already know the mass, my volume will be equal to nothing but total mass into specific volume. Because whatever the mass we are having, we have not taken out any mass out of the system. So mass will be remaining conserved. However, it will be converting from liquid to vapor. So my final volume or volume corresponding to state 2 will be nothing but total mass into specific volume. Is this point clear?
Yes, sir.
Now the last question is, I have to...
Sir, excuse me, sir.
Yes, please.
So can't we use V1 by T1 is equals to V2 by T2 because all the it has become all the vapor, means gas.
We cannot use, because while it has transferred from liquid vapor dome. So some part was there in the liquid vapor dome. That's why we cannot use. Clear?
Yes, sir.
Now if I go to next part, so last part is we have to present this process on PV diagram. So this is my pressure, this is my volume, this is my liquid vapor dome. So say this is a pressure line corresponding to say 800 kilopascals. So my initial point was somewhere over here. Now what we have done heating at constant pressure, and this we have done till our final temperature is actually 350, and this is done at constant pressure. So this will be my state number 2. Okay. So over here, nothing but I'll be having constant temperature lines. So I'll be having one constant temperature line somewhere over here. Okay. And then I'll be having some more. So this temperature line will be nothing but corresponding to T sat at the given pressure P1, and then I will be having one more line So I'll be having one more constant temperature line. So somewhere in this region. Okay, so that will be some another temperature T2 which will be greater than this particular T set. Okay. So this is my representation on PV diagram. Clear? This point is clear?
Sir.
Okay, anyone is having confusion on this point? All of you are clear with this particular point?
Sir, can you explain this graph again?
So what we are having pressure and specific volume axis. This is our liquid vapor dome and this is our constant pressure line of 800 kilopascals. Okay, now this is my point number 1, which is in the liquid vapor dome. After that we have added the heat at constant pressure. So our after heat addition we will be having a constant pressure line, and this we have done till temperature reaches to 350 degrees Celsius. Now if on this curve I draw the constant temperature line, so my constant temperature line 1 will be this T1 line, okay, which will be nothing but saturation pressure corresponding to P1, because this line is crossing the saturated curve at the given pressure of 800 kilopascal, and we will be having some another line which will be passing through this our final point, and this line will be having temperature equal to 350 degrees Celsius. Okay.
Yes, sir.
Okay, so let me now move to next question. So next question is there. Please explain the concept of pressure and work where piston was fixed with screw. What is reduced pressure and temperature? Okay, that is second part. And then third is why is Z less than 1 for critical temperature? Okay, so let me explain all three questions. First, let me take up the concept of pressure and work where piston is fixed with the screw. So it is nothing but what we are saying, that we are having a piston cylinder arrangement and we are having the piston which is fitted with some screw. Okay, and then inside we are having some gas, high pressure gas. So this pressure is high, and outside we are having surrounding pressure as P0, and some force F is acting on the piston, and MP is mass of the piston. Okay, so it means if you see from the external side, we are having total pressure. One is because of the force, so force per unit area. Another is because of weight of the piston, so MPG by A, and some is P0 pressure. So this is my external pressure, and I have told my gas is having very high pressure. So it means gas pressure is significantly large in comparison to the external pressure. Okay, so now if I plot this on pressure versus time diagram, so what will be happening? I'll be having this as my P external value. Now if you see this external pressure, each and every term is constant, so because of that external pressure will remain constant with time. Okay, however, if I plot the initial pressure P, that is very large in comparison to our external pressure, so that's why P is very, very high. So now if I just release this screw, so upon the release of the screw there will be a rapid or instantaneous expansion of the gas, and gas pressure will suddenly decrease. Okay, as the process was very rapid, so because of the inertia of the piston, we will have some situation that pressure will go below external. If it is going below external pressure, it will try to regain to the static equilibrium value. So because of that, piston will once again, so basically in this first fall process, what has happened, piston has moved in upward direction. Once it has gone below external pressure, after that what will be happening? Now the inside pressure will be less in comparison to the external pressure. So because of that, piston will move in downward direction. So once again, because of the inertia of the piston, it will overshoot this external pressure value, and this process will keep on going unless all the oscillations of the piston are damping. Okay, so till this point it is clear.
So have we assumed that the pressure of our gas is greater than the external pressure?
Yes, we have assumed. Yeah.
Okay, sir.
Okay. So now, if I have to write the expression of work, we know work is nothing but integration of P dV. Okay. So you can see that your pressure is actually continuously varying with time. Okay. So it means, and moreover, whatever the pressure was required to quasi-statically move the system, your pressure is greater than the pressure which is required to move the piston. So ultimately, it is only the external pressure which has to be overcome in order to move the piston. So that's why while we will be writing the expression of work, instead of this P, which is somehow sometimes overshooting and sometimes undershooting the required pressure because of the rapid nature of the process, we will be using exact pressure which is required to move the piston. So we will be writing our expression of work as nothing but integration of P external into dV. So this is the actual amount of work which will be done, because ultimately we have to move our piston against the external pressure. Okay. This point is clear?
Yes, sir.
Okay.
Oscillates a little to achieve thermodynamic equilibrium.
Sorry?
So
yes.
Two irreversible process oscillate a little to achieve a thermodynamic equilibrium.
Yes, it will be oscillating, and finally because of the damping, there will be many kind of damping, friction, etc., and it will be then reaching into thermodynamic equilibrium state. When the value of... Yes, Salis, you want to say something?
For every irreversible process.
Yes. Yes, if we are not giving any external excitation, then obviously after some time the process will be damping and it will be coming into equilibrium. Okay. Unless or until we are not giving any periodic forced oscillation. Okay. Now, second part of the question is, what is reduced pressure and temperature? Reduced pressure and temperature is nothing but are two parameters which are designed in order to plot the compressibility factor on a generalized diagram. Okay. Is this point clear?
Yes, sir.
Then next question is, third part of the question is, why Z is less than 1 for critical temperature. Okay, so let me explain. If I draw over here the compressibility chart, Z versus P reduced, and say this is nothing but my liquid vapor dome. So this is my critical point for which P critical is 1, and moreover, whatever the temperature line which will be passing through this point, that temperature line is also TR equal to 1. Okay. So now what I am saying that if we have any, if in this particular region, what we are having actually in this particular region, if you see, we are at the moderate range of pressure. Okay. So we are at the moderate range of pressure. So if we are at the moderate range of pressure, whatever our molecules are having, these molecules will be having nothing but moderate values of density. Okay, so these will be having moderate value of density. So because of that, what will be happening, whatever the molecules we are having, these will be having intermolecular spacing in such a fashion so that they will be experiencing the attraction forces. Okay, so molecules will be attracted towards each other. So in this particular region, what will be happening, if I talk about ideal gas behavior, so if with ideal gas behavior my volume was V ideal, so that volume was corresponding to the state where we are not having any attractions. Okay, so if molecules are at this particular distance, these will remain at this distance only because they are not having any attraction. However, if we talk about real volume, so in real state, what will be happening? because molecule will be experiencing the attraction forces. So because of the attraction forces, they will be coming slightly more closer to each other. So if all the molecules are coming more closer to each other, they will be occupying less volume in real scenario in comparison to the ideal. So V real will be less in comparison to V in ideal scenario. Now we know that our Z is nothing but equal to PV by RT, and it is equal to 1 when our V is V ideal. If we substitute over here V real, which is less than V ideal, then obviously our value of Z will be less than 1 in this particular zone. Is this point clear?
Yes, sir.
Okay, then let me take up next question.
Other than that, I had another problem. Can you, sir, explain the part where we have calculated H compressed for the compressed
Okay,
liquid?
let me explain it. So the first point you have to remember that while we have seen the compressed state, in the compressed state, our whatever the pressure and temperature are given, ultimately what we have to do, we have to go to saturation temperature table, and from the saturation temperature table, at the given temperature condition corresponding to its saturated value, we have to determine the value of specific volume, we have to determine the value of its internal energy of liquid, we have to determine the value of entropy of liquid. Okay. While we will be calculating the enthalpy, as enthalpy is nothing but equal to U plus P into V. Okay. So what will be happening if I plot, say, my TV diagram? So on this TV diagram, if I represent a compressed state, say this is my compressed state. Okay. So obviously this compressed state at this particular point, what I am doing, I am assuming its value at this particular point. Okay. So what is happening? I have got the value of U. So now I need to determine H for compressed. So H for compressed, I can write that whatever the U for compressed will be there, that will be nothing but equal to UF at T set. Okay. Plus whatever the V I have to calculate at saturated state, at compressed state, that V I can say that V will be equal to V corresponding to the saturation. So I can simply write over here V also F corresponding to T set. Now the only thing come into picture, pressure. So now if you see this saturated state, corresponding to this saturated state, we will be having some another pressure line which will be having, say, corresponding to this pressure as P set, and over there for this compressed state we have some another pressure line P2, and this pressure P2 is actually, or say pressure P, this pressure P is actually greater than our P saturation pressure. Okay, so that's why I have to multiply directly over here the value of this particular pressure. So this is one way. Okay, this point is clear?
Yes, sir.
This is one way. Now another way could be that I calculate the value of enthalpy at this point directly. So that way, let me just explain what I can do. I can write H compressed as nothing but equal to HF at T saturation, okay, plus P minus P saturation into VF at T saturation. So here what we are doing, basically we are considering the enthalpy at saturation point. So enthalpy at saturation point is actually already taking into account the contribution of P saturation. So that's why while we will be extending it for compressed state, that contribution of P saturation we will not include, rather we will include only the contribution of additional pressure. Okay, so this is another formulation which we can use. This point is clear?
Yes, sir.
Okay, so now then let me move to next question. Next question is, please tell, will work done in adiabatic process equal for reversible and irreversible process? So Aryans, it is better if I take this particular question in my subsequent lectures after we complete our discussion on the topic of reversible and irreversible process. Okay, so it is not a good idea to take this topic at the moment. Is it okay?
Yes, sir.
Okay, then next question is, Asutosh, you have not written any question. So beyond that, there is one more question, that PV power n equation, when n tends to infinity, we say V power infinity is very large, but it will be possible only when V is greater than 1. So is there this assumption of in equation of PV power? No. So basically what we are doing, yes, you have correctly pointed out that if we take PV power n equal to constant, if our V is greater than 1, then obviously our value of pressure will be 0, and if V is less than 1, then value of pressure will be nothing but infinity. So that's why if you see the formulation, while I have presented what I have shown, that this will be my n equal to 0 line, this will be n equal to 1 line, this will be n equal to gamma line, and this will be my n equal to infinity line. So either I can go to 0 or I can go to infinity, and same thing will be applicable with minus infinity also. Okay. Is this point clear?
Yes, sir.
Okay, so now I don't think. So we have more questions. So anyone who is having any question?
Yes, sir.
Yeah, please.
Sir, the question number 2 of assignment.
Question number 2 of assignment. Okay. Superheated water vapor. Please mute your microphone. Superheated water vapor at 1.24 megapascals and 260 degrees Celsius is allowed to cool at constant volume until the temperature drops to 121 degrees Celsius. At the final state, determine pressure, quality, and enthalpy. Also show the process on TV diagram. So what I'll be doing, I'll be only representing the process on TV diagram. Probably after that, you will be able to solve it. Okay. So I have temperature, specific volume. This is my liquid vapor dome. Now let me consider a constant pressure line over here, and let us consider this pressure is nothing but the given pressure is 1.24 megapascals. So 1.24 megapascal is pressure, and we have some point, say this is my first point, and corresponding to this temperature is nothing but 260 degrees Celsius. Okay. Now what we are doing, we are allowing it to cool at constant volume until the temperature drops to 121.11 degrees Celsius. So it means now I am cooling this at constant volume. So now you can clearly see my line that I am following constant volume curve, and I have cooled this till my temperature has reached to, so this is my state number 2, and at state number 2 temperature is 121.11 degrees Celsius. So now if you go to this temperature, it means our final state has nothing but entered inside the liquid vapor regime. So if you check, your final state will be there in between the liquid vapor regime. Now if you pass any pressure line, if you locate at this particular temperature, what is the saturation pressure, that will be your pressure. And if you know the saturation properties, then obviously you will be able to determine the quality. Quality is nothing but a synonym for dryness fraction. Okay, so we say many times our dryness fraction of the steam as the quality. Okay, so quality will also be coming, and enthalpy is also easy to determine. Is this question clear?
Yes, sir. Quality was the doubt.
Okay, quality was the doubt. Okay.
Sir,
Okay. Yes.
the question in the quiz about the structure change.
Yes.
So basically, structure change happens in chemical reaction, and inside the atomic change happens in the nuclear reaction. Am I right?
Yes. If changes are there within the nucleus, then we call nuclear energy. You please first mute your microphone. And if changes are there in the atomic structure or within a molecule, then we call as nothing but our, if change of molecule is happening or atomic structure is changing, then we call as our chemical energy. Okay. Now Asutosh has written one question. In today's lecture, you wrote polyentropic process. Shouldn't it be polytropic? Yes, I think I have mistakenly written polyentropic. It should be polytropic process. In case of specific heat, V is negligible, but V is not. And in equation, in total volume, Y VDP is. So while I am writing the equation, I am using the specific form. Small h is equal to small u plus p into small v. So that is actually the specific volume which I am neglecting, not the total volume. Okay. So is this point clear, Asutosh?
Yes, sir.
Okay. So is there any other question?
Sir, why latent heat is not called as stored heat?
So yes, what I told, under some circumstances, latent heat is also called as stored heat. So that it is called when it changes the phase from vapor to liquid. Okay. So while it will be changing from vapor phase to liquid phase, it will be releasing certain amount of energy. So during that time it is stored heat. But while we will be adding heat to change the state from liquid to vapor, at that time actually it will be absorbing the heat. Okay, so that's why we are calling it as hidden heat only in general. However, under some circumstances, obviously this heat can be categorized as stored heat also. Okay.
Yes, sir.
So there's a question that.
Yes.
So there's a question that in the quiz that states that which of the following approach is known as classical approach? So what do we mean by the classical approach? Isn't it the classical thermodynamics, about the thing about classical thermodynamics?
Yes, it should be classical thermodynamics only.
So, but in classical thermodynamics, don't we assume things at a microscopic level?
No. So see, when we talk about statistical thermodynamics, then we say that whatever the number of molecules we are having, we are doing their, we are finding their individual properties, and then we are using the statistical averaging. Over here, what we do, what we are perceiving at the macroscopic level with the help of our measurement devices, that property we are actually taking. Okay.
But sir, that's in engineering thermodynamics, right? But about classical thermodynamics, you said that it is on microscopic level only.
No, that is statistical thermodynamics. Statistical thermodynamics is at molecular level. When we say our classical thermodynamics, whatever the subject we are studying, so we are not talking about molecular averaging, etc. Means we have fundamentally understood why this is happening, but while we were analyzing our system, we are actually perceiving only the properties on the bulk level. Okay, macroscopic level. So that's why we call this subject as our classical thermodynamics. Okay.
Okay, sir.
Sir, I read on the internet that the rotational kinetic energy of an monatomic molecule is zero because it has very less or less significant moment of inertia.
Yes, yes.
So, sir, so the answer should be none of these.
Yes, that is what I told, that we are not having any correct answer over here. So that's why I am discarding this question. Okay. So
There
this
is
question
none of these is not correct.
that has created confusion, because if center of mass and axis also are coinciding in some cases, then also our rotational kinetic energy can be zero. So there were very confusing options. So that's why I am removing this question. Okay.
Yes, sir.
Sir, can you please explain the last question again?
Question number, this assignment question number 2.
Not sir, not assignment question. In the Excel sheet, the PV power question.
Oh, so it is in case of specific heat, that is V is negligible, but V is not. So that part
Sir,
or
the question, so the question below that in PV power n equation and
infinity.
that
Okay,
question.
okay, okay. So what we are saying, that PV power n equal to infinity. Okay. So pressure will be, sorry, PV power n equal to C, and we are selecting n equal to infinity. When n is infinity, at that time pressure will be infinity if our volume is greater than 1. Sorry, pressure will be infinity if our volume is less than 1, and pressure will be 0 if our volume is greater than 1. Okay. So it means, and at the same point of time, if I take n equal to minus infinity, situation will be different. Like pressure will be infinity for volume greater than 1, and pressure will be 0 for volume less than 1. So that's why my explanation is, when I am plotting it on the PV diagram, whatever this vertical line I am showing, this particular vertical line is corresponding to n equal to plus minus infinity. So it means whatever the general statement I am giving, that when n equal to plus minus infinity, our process is isochoric, that is applicable for all the volumes less than and greater than 1. Okay, the question was that it is only applicable for volume greater than 1. Okay. Is it correct?
Sir, don't we need to draw the graph corresponding to volume greater than 1 for two graphs and two graphs less than 1?
See, we are not saying that we are not specifically locating the magnitude. What we are saying, that whatever the volume V we will be having, at that V only. So yes, if you want to say that this is corresponding to 1, one more line you can locate behind it, which is say at V less than 1. That's it. That doesn't matter. So it will be a vertical line only. That is the main concern. Okay.
Okay, sir.
Irrespective of the
Usually when we are talking equations, so do we take an assumption that volume is greater than 1?
No, so we don't take, but whatever the given thermodynamic volume is given, at that given thermodynamic volume only we will be having straight line. Okay.
Okay, sir. Thank you.
In the rotation question that you have discarded, what would be the correct answer? I mean, for our knowledge only.
Rotational kinetic energy will be 0, that one or which one?
No, sir, the other one.
Okay, why it is 0? Okay, so just now I have explained. If you go to my this first slide, so in the first slide I have shown oxygen molecule. Just let me go to that part. So we will conclude in maths notes only. Yeah, so this was, so we may have a situation where our axis of rotation is passing through this, and for this diatomic molecule, our center of mass is lying on the axis of rotation, but while this molecule will be orienting, its atoms, whatever its mass points are there, for example, these are the two atoms, so one is having mass M1, this is having mass M2, so its atoms will be having certain distance from the axis of rotation. So obviously about this particular axis of rotation, it will possess certain amount of rotational kinetic energy. If I have axis which is oriented exactly along the mass and it is spinning in this particular direction about this axis, so here what will be happening, every time our mass of individual atom will coincide with the axis, so mass moment of inertia will be actually negligible. So the correct answer is that our masses of the atoms should coincide with the axis of rotation so that their mass moment of inertia is negligible. Okay.
Yes, sir. Got it. Thank you.
Okay, so now then I'll end up this session over here. And
Sir, I have a very quick question. Is it okay?
yeah, please.
Yeah. In the third question of the assignment, where it's given 2 kg of water in a sealed vessel at 100 degrees, should we assume that it's all in the vapor phase or is there some dryness fraction?
So that is not. First, you please mute your microphone. So you need not to worry about that. You can consider any state, okay, irrespective, because your other parameter is not specified, that what is the pressure. If pressure is given, based on that only we can conclude whether it is in the liquid phase, in the vapor phase, or in the superheated phase. Okay.
Okay, thank you, sir.